Let's look at number 7 in section 9.1. We're going to solve this initial value problem here. With this, of course, here's the initial condition. So the first thing will be to rewrite y prime as dy dx, and then I want to get the y prime by itself, so I'm going to add the 7y and subtract the 8. Now this is a separable differential equation. Okay, you got a function of y only here. Your function of x would just be g of x equal 1. So now I'm going to multiply by dx, and I'm going to divide by this whole quantity. You cannot simply like subtract 7y. Okay, that's not going to work. You can only multiply or divide to get this stuff over here correctly, because you want your dy over here and your dx over here. So I'm going to divide by the 7y minus 8 and multiply by the dx. So this is now, I can now integrate. This side's easy, right? This is just x plus a constant over here with a little substitution here. You can see how I get the antiderivative is 1/7 the natural log absolute value of 7y minus 8. So now we are going to solve for y. So I'm going to multiply by 7. When I do so, I distribute here. Of course, this will be 7c, but again, we're absorbing into c as much as possible. So this I'm just going to write as c. Now I exponentiate, right? The absolute value of 7y minus 8 will be e raised to this power. So remember, e to the 7x plus c is e to the 7x times e to the c. So again, e to the c is another constant. I'm just going to call it c. So this is c times e to the 7x. Solve for the absolute value of 7y minus 8, equaling that I have 7y minus 8 is plus or minus c. And again, plus or minus c is just another constant. Call it c. All right, so we just keep absorbing as much as possible into that constant c. I'm going to add 8 to both sides now, and then I'm going to divide by 7, once again absorbing into the constant. So c divided by 7, I'm just going to call a new constant c. So here is my general solution. Okay. Now, the question is, for this initial condition, what's the value of c? And remember, the initial condition was this right here. So I'm going to continue this on the next side. So we have y of 9 equals 1. Remember, that means 9 is the value of x. Therefore, y is the value of 1 in this case with this initial condition. So replace y with 1, replace x with 9. Of course, 9 times 7 is 63. And so here we get this. I can solve for c by subtracting 8/7 on both sides. And then I can divide by e to the 63, or the same thing, multiply by e to the negative 63. And I get c is equal to this. Okay. So again, I'm going to replace this c with this whole thing. And when I do so, I get this right here. I'm just replacing that c with this whole thing. And this is the solution. We can clean this up a little bit. Remember, e to the negative 63 times e to the 7x, I can write as e to the negative 63 plus 7x, or, which is a little prettier here, e to the 7x minus 63, same thing as that. So that's what I wrote my final answer as there, circled in the box for this particular solution. Again, your problem should be very similar to this, depending on your initial condition and the differential equation given. Okay, hope this helps.